In this module, we are going to understand what do we mean by code versioning control system. It's really important skill that a web developer or any computer science student should understand nowadays. So, what is version control system? Most of the time, when we are creating a files or when we update some of our files, that means we do a modification on our files over time. So let's assume here we first created this file here. After, let's say, next day we updated or added some of the information to the same file. So in the third day, we have to change this one, like this information that we added before. We want to delete it. In the fourth day, we added another data which is completely different than what we usually have. So in this scenario here, you are overriding every time, override what you previously had. So at this point here, if we wanted to revert back to the first file or the original file here, we will not be able to make it. Keep in mind, let's say if we have the modification or different modification for each day, that means we cannot revert back to the original file because each change will overwrite the previous or the current state of the file. That's why we have to have a different solution that we can keep up and we can keep keep track of all these changes over time. As I said, like one of the downsides of using like just a regular save mechanism, usually we will overwrite previous versions. We cannot provide any retrievement of the previous version of the files. To overcome these problems, one of the solutions that we may use is to save a different version for each change. So let's say for today's modification, we will have a directory, or we can call the name with, let's say, day 1 file. For the next day, we will create another file, or we copy and paste in the same location and change the name. As you can see, this is not an easy job to do it, even though like if we can use like Google Drive or Dropbox, or even like use USB thumb drive. This is like one of the main problems. If you wanted to use this solution, then we might have storage issues, because the more files you add, the more storage you're gonna get. It's really hard to manage, especially when you are talking about like multiple files. And as a web developer, when you build your application, for sure it's not gonna be just like one file. It's gonna be multiple files based on like how many, let's say, services do you have in your web. The most important part, which is error prone, which is like once you made a mistake, you cannot revert it back. This is like one of the downsides if you want to go with like the traditional, or let's say the classical way of managing versioning. Instead of that, people came up with another solution, which is called version control system, where this version control system is used to record changes to the file or multiple files over time. So you can, at any point, you can revert back to a specific version of that file. So one of the solutions proposed by people, which was local version control, this one keeps all the changes in a specific database. The most common tool is called Revision Control System, or RCS. The way RCS works is by keeping patch sets, which is the difference between the current version of the file to like the difference between the version 1 and version 2. From these differences, we can reconstruct the differences and we can just revert back to any previous version of the file. So, seems like it's a good idea, but for sure there were like some downsides which make like local VCS is not like adaptable by anyone. So one of the main problems that arise when we use local VCS is there were no collaboration. And as you can see, like when you are building your web application, you are collaborating with other developers to build one application. In real life scenarios, most of the time, at least you will have another developer who works with you to build a specific application. So you need a way of collaboration. So if you want to collaborate or share the file with someone else who's going to work with you on the same code repository, you have multiple options. One of the options that like the one might think of, we can use, let's say, shared directory on Google Drive or Dropbox, or I can just email it to him. But the problem is, the more frequent that you made changes, the more updates you have to send and share with your colleague. That's why if you are eager to do, like, let's say, a collaboration with some other developers, then you have to think twice before you make decision to use Google Drive or share your code through email. Another downside, even if you choose to just share your code through the email, then might, like some email provider might block your code because it's going to be, for them, it's going to be like security threat to their system. Another downside for local VCS, which is if the hard disk fail, then the whole project is corrupted. You cannot revert back any version of your system or your code. That's why usually local VCS, we call it like single point of failure. If you fail to restore your data from the hard disk, then the whole project is not retrievable. So some people came up with another solution to overcome, let's say, the problem with the local VCS. They came up with a centralized VCS. When we say a centralized VCS, it doesn't mean that it's just like one server. We might have multiple servers where these multiple servers are mirrored together, but they are all served as one centralized repository. So as you can see here, the developer will have access to the shared repository. Here in the shared repository, we might have one server or multiple servers, but like the sense of centralized here is just like one location that holds all your code base. So if we have 3 developers who are working on the same code, then, or let's say the same web application, as you can see, all the developers, they have a connection to the shared repository. In this scenario, it's really like really good to go with it, but the problem, or the main problem with this one, is the management here requires very tight coordination between developers. Every developer should know what the other developer is working on, because let's say we have file number 1 on all the code base here. Let's say developer 1 updated or modified this file 1.html here, and developer 2, it changed or modified the same file, and both of them pushed their change to the shared repository. Who comes first will be stored. So who comes last, the latest version will be the latest version here. Sometimes some, let's say, override would be happening. So let's say if this guy here, let's say developer one, change the file and add functionality, a specific functionality. Here, this guy add another functionality to the same file. When this guy, let's say, push his change, let's say on Saturday. On Sunday, the other developer push his code. Some of the VCS or centralized VCS will override the file that it's been pushed on Saturday. So this is like one main problem. Another main problem, which is centralized usually leads to single point of failure. So even though if we have like multiple mirrored servers here, we still have one single point. What if the network goes down for the whole server infrastructure, for all the servers? This means we cannot just access and we cannot synchronize our work between the shared repository and developer. So in this case, or in this paradigm, without persist connection to the repository, we cannot use VCS. People, after like all these kind of problems, they came up with distributed VCS. In distributed VCS, we have a remote repository which holds all the files. In addition, every developer will have a copy of the server information. So in this case, the code, it's not saved only here, it's saved everywhere. As you can see, the arrows here, let's say the data exchange is done on both sides. One of the examples of this distributed VCS is GitHub, or the protocol itself, or the standard it's called is Git, but one of the implementation of Git is GitHub. So in this case, if the server is down, I still can have backup from any other developers. But in the centralized VCS here, if the server goes down, then I cannot just get copy of the whole repository. I can get copy of developer one, which might not be a full backup, even here, even here. But when we are talking about distributed VCS, that means we have a copy that we can use as a backup for the whole code repository. Okay? So, as we said, like one of the examples of distributed VCS is Git. So, what is Git? Git is a distributed version control system which uses snapshots, not change differences. And we will see in a moment what's the difference between snapshots and change differences. The good thing about Git, it takes the advantage of working on local. So if you have like some connectivity issues, then you can do all your work on local. Once the connectivity is back, then you can just push your changes to what you have and resolve any conflict that might arise. Another good thing about Git, which is integrity enabled. So each change you make to your code repository is integrity checksummed. This means you can always, or there's always a way back to a previous version. So what's the difference between VCS differences and VCS snapshots? So let's assume we have 5 versions of our protection or our code base. So in the first version, we have file A, B, and C. So in version 2, we updated just like 2 files, files A and files B. In some of VCS, we just like count the difference between file A on version 1 and file A in version 2. So as you can see here, delta 1, which means this is like the delta between file A at version 1 and file A at version 2. As you can see, file B has been changed in version 2 nor in version 3. So the first difference will be counted after we made the first modification, which is going to be on version 4. As you can see here, the VCS differences is the difference between each version to the next. If the file hasn't been modified, then it won't be counted to the differences. This is the way that, like, if we are building this way from version 1 to 5, if we wanted to revert back to any file at any previous version, then we can just subtract the delta to revert to a specific version. So let's say if we are at version 5 and we wanted to restore the original version, which is the version 1 of file B, for example, we'll remove the first delta, then we will remove the second delta, then we will end up with the original file. As I said, Git is not using the same paradigm. It's not using the differences. And instead, it's using snapshots. How does snapshots work? So snapshots, it take a snapshot of your current directory for each version. As you can see, here file A, B, and C, you made changes on, let's say, an A and B. You still can take, you made change on A and C, you still can take B as a snapshot. As you can see, the changes here. So in each version, you have a full list of, or let's say, a full snapshot of the changes you made on your code repository. How does it work? Usually, you will create a remote repository. You might use GitHub, you might use Bitbucket, even you might set up your own server or Git server. And let's say, for example, if you are working in a company that has their own internal Git server, then you still can use the same command, because as I said, Git is not just like a GitHub or Bitbucket. It's just a standard that you may use. Some of implementation that has like some support for specific commands and the other are not, but in most cases, the most basics commands, as we will see, it should work fine, either to work with GitHub or Bitbucket or any other Git repository providers. So at first you could create your repository in one location. Then on your local, you will pull this repository to your local, and you will do all your modification here on your local. Once you are ready to push your changes to the remote, then you will use push mechanism to push the changes from the local to remote. When we say pull, we are taking the database from the repository here, or copy it from here to here. And we will keep updating on this database. And when we are trying to push, that means we are to synchronize the database here with the database on the remote. So when you are working with Git, there are like some states that you have to understand. It's really important to understand how does it work. So let's say you have a directory, and this directory is Git enabled. And we will see in a moment how you perform all these stuff together. But it's important for now to understand how does it work. So let's say you have a Git enabled directory. and you start to add your files, modify some of the existing files. You have 4 states. Usually people say it's 3 states, but for me, I like to call it 4 states. So the first state is untracked. So untracked usually is like a stage for the files that you newly added. So let's say you have a git enabled directory which is like has 3 files, and you add a 4th file. The 4th file will be at the stage of untracked. The way it's working, Git will monitor the change on the files, and it will tell you that there's like some modification for the directory, but I have no idea about this file. I have no clue about this file. So this is like the first state. The second state, which is the modified. The modified is you made the changes to the file, but you haven't committed yet. Or just like you added the file, you change the file. To be able to add this file to the next commit, you have to do or to move it to the staged state. The staged state, it's usually done through git add. Okay? Once you are done and you have all the files is done and you know what kind of files you are going to push, then you have to commit your changes. After that, you will do the, let's say, the push modification. We will see all these in action in a moment, as I said, but it's important to see at least just like keep it in a piece of paper next to you. So when we are trying to work some of the examples, then you will have a clear idea about the states here. Another important topics that a web developer needs to understand is the branches. In most cases, in most application, as a web developer, you're not gonna be like the only developer who's working on this project. You might have like multiple developers who are working on the same project. So in most cases, you will have your own branch or on the feature that you are working on. Once you are done with working with the features you have, then you can just merge back. So the way it's working, you branch off the master, then you have your own branch, you will do all your work there, and once you're done, then you can just merge back to the master. So let's say, in this example here, we have 2 developers. The first developer who's like this color, the purple one, and the other one, which is the blue one. So the timeline for our code base here is the green one. So this is the master that we call it usually the master branch. When you start with master branch, as you can see here, the files, file 1, version 1, all these 4 files, it's going to be on version 1. So the first developer just branch off the master and start to implement the feature that he wants to implement. As you can see, at the first commit, he changed the file 1 and file 3. That's why we have version 1.0.1. And he made the first commit, let's say at the first day. So on the second day, he added some another changes to the file, to the same file. So he committed, then he merged back from here to this point. At this point, what we are currently have on the master, we have an updated file 1 and file 3. But as you can see, file 2 and file 4 is not updated. Here, at like a specific time, the other developer started to work on his changes. So he updated file 2 and file 4. And once he's done, then he will merge back at this point. As you can see in this point here, we have only 2 files modified. On this one, we should have 4 files. Why? Because here we have 2 modification, and from this branch we have 2 modification. So for you as a developer, in most cases, you will have your own branch, and if you are working on a really big web application, 2 or 3, let's say, developers might work on the same branch. So the case of branching is not only to branch off master. You can make your own branch from a sub branch. So you can create an unlimited branches. But the rule of thumb here is whenever you are branching off the parent branch, you have to merge back once you're done working with the thing that you are working with. Okay? And you will see it in action. How does it work? So for this one, I want everyone, from you, to create your own repository. Once you sign up with GitHub, then you create your own repository. Let's say we will have this repository, we will call it network-based course. I will copy this one. This is the first stage, which is just creating the first repository or remote code repository. From here, you must install, let's say, install one of the command line. If you are using Linux or Mac, make sure it's available from your command line. If not, then just try to find a way to install it. It shouldn't be that problem. For Windows, I'm using Git Bash, which is a really good tool that you should work with. So let's say I wanted to clone the remote repository to my local area. So what should I do in this case? I'll take or copy this repository link and I will use git clone as you can see, I added. Now, I just create a copy of this repository to my desktop. So if I see ls here, you can see I have network-based course, which is the same GitHub. So now let's go to desktop. Network-based course. The good thing about Git Bash is give you the name of the branch that you are working on right now. In the first milestone, you will have a requirements to create multiple branch. Okay? And we will see now how to create some branches and we will see how does it work. So as I said, once you create the first remote repository, first you create a copy on your local, then you pull the changes, all, let's say, the code repository to be downloaded to your local database. To pull the data, you can say git pull origin. It's gonna pull everything from your remote. Since we have nothing in there, then everything is up to date in here. So let's create just one file in the master, for example. let's say echo hello GitHub. I want to add it to readme.md, for example. I want to check like what's the status of the current directory. Is there like any new file? As you can see, this file is untracked, which is like the first stage. Untracked means there's some differences in the current directory, but as we said, it's not tracked. We have no idea what kind of changes, whether it's important or not important. So how to move your file from untracked stage to the next one, which is the modified one? We can say git add, and we just type the file name, or if you have multiple files, which is like usually I like to do, is to use -A. It's gonna add all the files. If you add like, let's say 100 or 1,000 of files, then with this file, instead of just like typing all the files name, you can just like use git add -A. Now let's see git status. As you can see now, it changes to be committed, which is at the stage of the modification. And usually the untracked files is going to show here in this tool, which is a git bash. It's going to show in red, and the tracked or the modified stage will be in green. So to commit your changes, we can say git commit m, and this is the message of your commit. Usually you have to have like, let's say, a meaningful message. You should add it here. Let's say here added readme file, for example. As you can see, one file changed, insertion. If you go now with git status, you will see nothing to commit. Everything is up to date. Now, which is like most of the students will make this error. They will think once you commit, that means you have pushed your changes. But this is not the case. So if you come here, as you can see, there's no code here. If you click in code, there is no code. Why? Because you haven't pushed your changes. So to push your changes, we'll see git push origin. Git push origin is going to push the changes from your current directory to the remote directory. Let's see. As you can see, it's just pushing your changes. Now, if you go to GitHub here, you can see this is like the files that you create. And you can see here from the commits, you can see added readme file, as we mentioned, or this is the message that we specified when we did the commit. And as you can see, we only have one branch, which is the master. As you can see, this is the only one that we have. In the milestones, you are required to add some of, let's say for each module, you will be required to add a specific branch for each module. How to create a specific branch? So the way it's working to create a new branch is git check out, then we'll use the option B, and then we'll write our, let's say, branch name. The branch name must not have any space, as like you name any variable. So the branch name, usually I would like to have it like in this way. All small letters with underscores if I want. Let's say examples. Okay? Now, as you can see, a new branch has been created and you switch to the new branch. As you can see here, master, this was like the branch, and this is now the new branch. Okay? Now, you are a new branch. You will get get status. You have nothing because you haven't added anything, right? So what if we want to have this branch pushed to the remote repository? In this case, let's say I want to add a new file. Let's say echo HTML branch readme, for example. Let's say html.md, for example. Okay? Get status. We'll see it's untracked. Get add get commit added a new file. Now, this branch is considered to be local, right? The master was remote. And once I copied like the repository from the online to my local, everything has been copied to my local repository. But here, in this case, I have HTML examples as a local repository, and I wanted to push it up to the remote repository. So I would use git push u or we can just like u HTML. I believe it's this way. Okay. Yes. So this is the command push set upstream origin HTML examples. As you can see, this is like the new branch. If you go here, you can see this is like there are two branches now. As you can see on master, we only have one file. On HTML examples, we have two files. The previous file from master and the new HTML file. Okay? So in most cases, this is what you should do. You will create your own sub-branch to create your own work. Once you're done, then you have to merge back to the parent branch. So in this case, the parent branch is master and the child branch is HTML examples, right? So to switch to the master or to the parent branch, we can just use get checkout and the parent branch. As you can see, I switched now from here to here. To merge these two branches together, I can do something like get merge no fast forwarding. What this command does is I want to merge this one with this one. So I want, in other words, I want all the changes that I've made on HTML examples to be available on master. Here, you will have to write like the message. In most cases, they will have like merge branch, HTML examples. Here, just write anything. Once you're done, you can just use colon, write, or type W and Q. That means the action that I want to take now is write these changes or write the message to the file or to the commit, then quit of the file. As you can see here, merge made by recursive strategy. The thing is, when you are working with multiple developers, then you might have some conflicts. In this case, you have to resolve this conflict, then redo the merging. But since here, I'm the only one who's working on the file, then it's okay. Now, if we check here, let's say I want to check what kind of files do we have here. As you can see, I still have only readme.md here. The thing is, most of the students will make their changes on the local and they forget to push their changes up to the remote. So please, please, please don't forget this. Once you're done and you want to push your changes to the remote repository, use git push origin. It's gonna push everything you have to the repository. As you can see here, now we can see like this is 3 or 2 files, and we can see here there are 3 commits. This is the first one, this is the second commit, and this is the commit for the merging. And as you can see here, these are like the checksum for each one. You can see here the code or the snapshot of your system. What was it? Okay. One last thing here, which is I talked about the branch. In most cases, if you are using this one, it's easy. Or I mean, if you are using git bash, it's easy. If you are using like any other command line, usually you won't be able to see this branch here name. So to get a list of all the branches you have in your local repository, you can see git branch. These are the branches you have, and the one or the branch that has starts before it, that means this is like the current branch that you are using. So let's say if get checkout HTML examples, and we see git branch again, you can see the one that has start before, this is like the current branch. So in the first milestones, you will be asked to create multiple, let's say, branches, and you will be asked to create some files to work with. Make sure to follow what we said here. It's almost the same thing. And there's another file posted on Canvas, which is like considered to be a reference for you. Whenever you wanted to work on Git, you will have like the process that you should follow and the commands that you need to work with. Thank you for listening, and I will see you in the next module.